Engineering is part of our daily lives, and today we talk about it with Maria Erquiaga, an engineer and a standout physicianeer in the making. Originally from Sarasota, Florida, Maria graduated Summa Cum Laude from the Catholic University of America with a degree in mechanical engineering and minors in chemistry and philosophy. She also received the highest honor, the President's Award, for her exceptional leadership and scholarship. She made history as the first undergraduate to be inducted in both the Phi Beta Kappa and Tau Beta Pi honor societies, which honor exceptional academic achievement in the liberal arts and science and also engineering. Now a member of the class of 2028 at Texas A&M Innovative Engineering Medicine program, Maria is pursuing her medical degree, which together with engineering will shape the future of medical innovation. Let's welcome Maria and talk about the exceptional journey that has taken her to this stage in her career. So I have a question for you. Looking at your career, why you decided to study engineering, and in particular, why mechanical engineering?
Sure. So I was first exposed to engineering. I attended the Cornell summer camp Catalyst for high school students from diverse backgrounds. And I was able to participate for 2 weeks with about 50 other students, just getting exposed to the different types of engineering, building some of our own networks, transmitting data. But I remembered two talks in particular. One was by a material science professor at Cornell who was discussing how nanoparticles properties change compared to when you've got the substance at large, which I thought was fascinating. It hadn't occurred to me that substances could behave differently on the micro level or the nano level than they did in the visible, I guess, macro level. The other talk that really stood out to me was a mechanical engineer, Professor Robinson, who was working with soft robotics, which is essentially exactly what it sounds like, but robots, but rather than using steel or other hard pieces, they use rubber, they use flexible electronics. And he was able to create some really lifelike, I believe at the time, his main model was starfish. And I remember seeing the video of these robotic starfish and just going down the street and that really appealed to me. I remember being a little conflicted whether I wanted to apply between material science and mechanical engineering just because I loved both of those talks. But I think ultimately the breadth of mechanical engineering appealed to me. You can do almost anything with a mechie degree, including material science. So I thought that no matter what I chose to do, whether that was medicine or whether that was engineering, or as it turns out, both, that a background in mechanical engineering would pave my way towards the best possible success.
Yes, and that's very interesting because after you finished that, you graduated, you decided to go into medicine, and you were mentioning that you got interested. So you planned it that way when you started mechanical engineering. You were convinced that you were going to go into medicine.
Yes. I am very fortunate. My father is a physician, so I had a very early exposure to what medicine was like from the doctor's side. Um, and I remember I was maybe 5 or 6, and he would bring home x-rays with the patient's names sharpied out, and I would spend hours just like ogling over what bone is this? What is this weird thing here? Um, But I've also had several family members with some pretty serious health conditions. So I've also gotten to
Mhm.
see medicine from the patient side as well and see some of the disparities in communication, some of the things that we don't have solutions for that maybe doctors aren't thinking need to be solutions, but to patients, that's their number one priority. Just some of the breakdowns in priorities and communications, et cetera. Um, and so I'd always been interested in the science of medicine with that early exposure. But as I grew older, I became more and more attracted to the art of medicine. And with my engineering background and my ability to look at problems and try to figure out how to fix them, try to articulate them, figure out like where exactly the issue is and solve them, I wanted to dive into medicine with the same mindset, finding problems from every angle and taking care of them.
Wow, that really sounds fascinating. Just to think how you had a plan, very well defined plan. So I actually met you through one of your professors. That it was Dr. Otto Wilson, and he actually talking about origami. He told me that you went into a class with him, and you also even were very interested in design things with the origami. So first of all, let me ask you, did you enjoy this class with him?
I did. I took it my senior spring, and it was definitely a fun class to end my career at Catholic U with.
Oh, that well, yes. I mean, I think that he's also a uh,
Yes.
very good professor. So, and then when you went to Texas A&M, he mentioned that you were very interested in the application of origami to medicine, and you started a website that it was called Medigami, you had a collection of origami patterns for parts of the body. And actually, I was looking at that, and looks very interesting. So, first of all, what motivated to create that website, and um, what does it mean to have the the mechanistic of the medical subjects that you mentioned in your website?
I was studying for my first exam in embryology, and we were discussing how you go from the single cell to the 4-week embryo, which has a lot of the characteristics of a newborn baby, actually,
Mhm.
on all of the tissues. Like we can trace at this point, we've been able to trace a lot of the tissues in the newborn baby back to these tissues in that trilaminar disc. So I was really struggling to kind of piece it all together and figure out how it went from one step to the next. And to take a little bit of a study break, I decided to start folding some origami, just to keep my skills sharp, what have you. And I remember I was folding just a classic water bomb base, and I thought about it for a minute. I was like, wait a minute, this feels an awful lot like the trilaminar disc. And I tinkered with it a little bit, and I realized that there were some steps beforehand that I would have to build a separate aspect for, but just toyed with it and wound up coming up with a model which it does take quite a bit of imagination to look at it and see, oh, sure, that's the trilaminar disc. But mechanistically, the steps of the folding correlated to the steps of development. And I used this to teach a couple of my friends who were also struggling. We just sat down and folded origami and talked through it. And it wound up being really helpful. We all got these steps down pat. And even I just took my first boards exam a couple months ago. This whole process started, gosh, 2 years ago now. But I barely had to review my embryology from that pattern because I remembered, oh, I fold like this, and that's the cells dividing. I fold like this, and this is the second layer tucking under the other. Um, and so that sort of grew as I continued through my basic medical education through the academic side of things, the textbook, if you will. I kept an eye out for folding patterns, and some of them are better than others. But I did start compiling just sort of a running list of, oh, this would be cool to try to fold. This would be cool to try to fold. And before I knew it, I had a list of like 20 patterns that I wanted to make and 3 or 4 under development. And I was like, oh, shoot, maybe this is something I should share. Um, Now, I'm a mechanical engineer. I don't do software graphics. The website is a Google site and it is incredibly messy. Um, but I wanted to be able to have a space where people could look at this and learn for themselves, where it wouldn't just be me sitting down with my classmates and showing them how to fold and talking them through it, but ideally something that could become a resource for all students. Which is why even, gosh, 6 months ago now, I opened up Medigami, just some quiet advertising, different sites, and origami societies around the country, seeking input on pattern design. Um, because really anyone, once they've understood the mechanisms and can try to put it together, anyone can develop anything out of origami. That's part of the appeal of it for me as an educational tool, at least, is, oh, I can take this single sheet of paper and turn it into whatever it is I'm imagining, as long as I've got enough of an understanding of that process and of the basic principles of origami. Um, so it's been a lot of fun to put that together, to see the occasional pattern that comes in from someone else. And yes, to figure out how things fit together on paper and in the human body.
Yeah, and actually, when I was looking at those patterns, for example, you have one that is of the stomach pattern, and that was the simplest to make in principle, but it didn't look like the picture. So, can you tell us, for example, what particular part of the stomach relates to origami, and also for what you said, it seems like what you developed was something that reflected how it formed.
Yes, so here's the Medigami site. Again, it's nothing fancy. It's just keeping a running log of what I've come up with and making sure it's available. But in specific regard to the stomach pattern, so the entire gastrointestinal tract is kind of tricky to think about because it starts as a tube. But so it was very important to me that the pattern started as a tube, because that's how it starts developmentally. But a big principle of the development of the GI tract and of the stomach in particular is that it folds back and forth, right? It folds one way to accommodate the growth of the liver, it folds the other way to accommodate the growth of the spleen. And that's really hard to visualize, right? We would like to think that the stomach shape's sort of like glass blowing. If you've ever seen a bottle being formed, how they just blow and the different amounts of air open it up in different ways. And it's actually a lot more complicated than that. It gets folded this way and that squelches it one way, it folds the other way, that squelches it another. And in coming up with this pattern, I was less interested again in what it looked like and more in making sure that I could fold it in a way where I understood it. So it was less about getting the shape exactly right, but to see, okay, this part outpouches and then it's got to rotate. This part folds back in and it's got to rotate again. This part outpouches. The shape you can see, it's not perfect. It's meant to be more of an approximation than anything. But you've got that 90-degree fold back and forth in different axes. That is one of the trickiest parts for students and certainly me to understand.
That's super interesting to see. And then you challenge people also to do the same, right? To try to mimic how the organs form.
Yes, I actually got this really impressive technical model from a young man online who was really interested in going to medical school. And we chatted for a bit. I'd posted it on an Origami community forum. I'd read up on how the myocardium particularly developed. Now, the heart is tricky. The heart, we learned by folding a towel back and forth until we got the hang of how it bent. But he was able to fold up this beautiful pattern, detailing the folding of the myocardium in tandem with, I believe he linked the paper at the bottom even. So self-taught, not even a medical student yet, but taking this concept that he learned from a readily accessible research paper and folding it into an origami model that certainly I learned from when it came time for me to review cardiac anatomy again, or cardiac embryology, and that others can learn from as well.
So, well, thank you so much for showing us your website, and I hope that you get more movement people. I know that you are super busy, so you cannot keep up, but maybe in the future it will be something that you can do in your spare time.
That's the hope, yes.
So one of the things is, for example, you had a background in mechanical engineering, and how do you plan to combine those two knowledges?
So my vision, and everyone in my class takes it a little bit differently, just because the idea of a physicianeer is such a new concept. My vision personally is that I want to be the physician who can walk into the patient room, see the problem and understand it from the medical perspective, from the patient perspective, from the healthcare perspective, and then go take it to the research and development teams, the engineers, whoever else is working on this problem from the scientific research technical perspective, and make sure that we're all on the same page. A lot of healthcare innovation, as I've learned, is not addressing, how to put this, they're beautiful pieces of technology, but sometimes the problems they're addressing aren't really the patient's problems, or they aren't diseases that we're really looking to treat. And so making sure that we're all on the same page, we all know, okay, here's the issue, here's what needs to be solved. If I have an idea for a solution, ideally I can start talking to teams and figuring out, okay, this is what I've seen as a doctor, as an engineer, this is how I think we need to fix it. How do we get this through? And so it's very much an idea of acting as a bridge between both worlds to make sure that they're talking to each other and working with each other as best as possible.
So that would be the difference, for example, between what you are doing as a biomedical engineer, you will be communicating with biomedical engineers, or what makes it different?
I think that having the clinical perspective of treating the patient and knowing the patient on a personal level, that I am afforded the privilege of practicing as a physician, allows me to really understand the problem from that clinical perspective. It's not just here's the problem as published in the literature. It's here's the problem as I know Miss Smith was experiencing it. And to have both that personal motivator, but also the experience of I've seen someone deal with this. I know what it looks like. This thing that might work in theory may not, because in practice it looks more like this.
Mm.
Um, and while I have every expectation, I should clarify. I want to work on a team with biomedical engineers, with other clinicians, with chemical, mechanical, with the whole spectrum of skills and tool sets that we can use to solve problems. Personally, I wanted my tool set to be bridging between these two domains in as effective a manner as possible.
So how do you think having this dual kind of knowledge put you in advantage with other physicians? I mean, with other medical doctors?
Um, I think it's less about advantage and more about being able to communicate and solve problems with my team. I think I bring a different skill set to the table. I bring a lot of I bring the same skills of a traditional MD, hopefully, once I've gotten through my education. 2 years left. Um, but 2 years and residency, beside the point. Um, but I think also being able to say, okay, there's a problem, here's a solution, let's implement this. Um, gives me the opportunity to work with broader groups of people than I think a typical physician might when it comes to identifying and solving problems. I think it gives me more of a technical set of, okay, I have this problem. I don't know exactly what the solution looks like, but here's 3 possible steps I could try, and bring prototypes. I know a lot of physicians who come talk to my class, they have ideas. They have, okay, this is a problem, we need to fix it. But sometimes that's where the process stops. And it comes down to the physicianeers and the physicianeers in training, to be like, okay, this is an interesting idea. What if we tried this to solve it? I don't know if that makes any sense.
No,
Um,
yes, it does make sense. I see you have acquired the tools that gives you the ability to see the possibilities to solve the problems, as you have been saying, that you know kind of what is possible, what a physician that has not studied that, he just probably with certain knowledge believes that there might be a solution, but does not really know how to, or if in reality it's possible. I think that you have more of that knowledge to to know how things work, or yeah. Yeah, thank you. I mean, I think that your career is wonderful and what you are doing is great. And I like the connection with engineering, that there is something that I think engineering is opening a lot of possibilities, and also to be connected as directly as with medicine, and you are pursuing that. It's wonderful. So thank you so much for giving this opportunity to interview you, because I think that it is important for people to understand the possibilities and get excited to pursue this kind of opportunities. So thank you so much.
thank you,
And
Dr. Diaz.
yeah, so I hope to be able to talk to you other time.
Thank you.
I hope that you enjoyed this interview and learn a little more about engineering, how integrated it is in other fields that maybe you never thought it will, like medicine. So if you want to continue hearing more about engineering advances and applications, please subscribe or visit our website at www.bridges-strong.org.